Oh, hello, everyone. Welcome to the tutorial. This is the online tutorial for ECON3350, Applied Econometrics for Macroeconomics and Finance. Some of you might not be used to having a tutorial in week one. And the idea for this one is just to make sure that every student has both R and RStudio installed, and also do like a refresher for using R. I will assume that most of the students have already used R, because you probably, the prerequisite was Econ 2300, and I understand if you did, for example, BAFE, you probably use R in some finance courses. If you do economics, maybe other type of econometrics courses. But before I start everything, I will tell you, we need to install R from this website, cran.rproject.org. And then install RStudio. So two things, all right? And I will start with presenting myself. I'm Francisco Tavares Garcia. I was born in & in Brazil, in São Paulo state, and I did a Bachelor of Computer Science from 2004 to 2008, worked for Procter & Gamble. It's the owner of Gillette for a few years. Then I did an MBA while I was working there. Then I left to open a hostel. And finally, in 2021, 2 years ago, I started studying a Bachelor of Economics, and I'm starting the 3rd year of economics this year. I have been pretty much full on econometrics and statistics. So I've done almost every course that is offered for us, plus added a few statistics ones from the School of Mathematics. And yeah, so if I'm not doing micro or macro economics, I'm doing econometrics. So this is a very quick background. The assessments for this course, I would assume that you guys have already watched the recording for the first lecture from Eric, and also had a look at the ECP. But just a quick summary. There will be some online quizzes, 5 of them. If you, by any chance, you check on ECP and you notice they were saying 10 minutes, this is not accurate anymore. You will have a few days to do it. I looked again. I studied this course last year, and I couldn't find exactly how many days. It's either from Monday to Friday, or a week, or maybe even more than a week. Honestly, I couldn't find exactly, but it will be a few days. So there's no rush. You can do a little bit, save, come back the next day, review what you did, etc. That's how it works for the quizzes. For the reports, you will see that report 2 builds on report 1. So it's really worth it to invest some time doing report 1 really well and understand what you were doing, because the more you understand how to do report 1, the easier it will be report 2. Probably report 2 kind of, I won't say a breeze, but it definitely makes it easier. I myself end up spending a lot more times doing report 1 than report 2. Okay. Other than that, if you need help, there will be consultation almost every week. Eric has a consultation Monday and Thursday. Let me open that. So if you go to your course, 3350 course stuff, Eric will be offering from 9 to 10 on Monday and 9 to 10 on Thursday. And you also have consultation from tutors on Thursday and Friday. I think something changed here. I thought there would be a Wednesday too, but yeah. So Theo in the afternoon Thursday, end of the day for Hal, and myself in the afternoon on Friday. Okay, so if you need anything, any help with something, almost every day you will have someone to chase. Probably if it's the end of the lecture with Eric, he will be happy to help you here, or end of tutorials with us. So virtually every weekday. That's it. Other than that, you probably I sent an email today. We activated Add Discussion Board. you will see it's much nicer than the standard discussion board. If you're doing a dual in math and economics, you probably saw Ed before. It's a nice thing. You can, if you need to write some type of equation, you can use LaTeX to make your equation look good, but you can also paste a picture. And it's possible to create a little snippet of R code that can run. So if you have a question, you want to add something that needs to be processed in R, that's an option too. You will see, if you have a chance, try to explore a little bit, add and see how to post. It seems like in my experience, students like interacting more in add than the standard plain discussion board that we have for other courses. For emails, if some difficult question, something to be explained, or regarding marking your quizzes, you can email Eric. Otherwise, if it's a more administrative question, you can send it to econ_admin, and Courtney is our the person helping this course. It's our admin. And if it's like something that is not related to the content of the course, but like enroll into tutorial, something like that, you can talk to her. Other recommendations that Eric gave, and I would like to add 3 free books here. None of them are the book that will cover the content from this course. But if you want to explore a little bit more or learn a little bit about R, we have those 3. This first one is an introduction to R. The second one is one that we tend to use with ECON3350. And the third one, it's a book on forecasting. That it's a little bit of some of the things we will do will be forecasting. So that explains in a different way. So important, it doesn't cover the same content. So it won't be enough if you want to base yourself just on the book. But if you're interested, something to have a look, this Forecasting Principles and Practice, 3rd edition. All right. Now, if you guys are still, let me double check if I'm recording. Sorry. Yeah. Sorry for that. So if you guys are still haven't been able to install, I will go step by step if you got stuck in part of the process. And first, the website for R. This is not RStudio yet, it's R. You could just Google install R, for example, and you come to this CRAN, and this is the last version. I think the link will just take you straight to Windows, and you can click download R 4.2.2, most recent version. If you have an old R, I would consider installing the new one, like overwrite the one you have or uninstall and install. So you make sure that things will be running okay. I had students in the past that couldn't run the functions because their R was too old. And so this is R. If you're having a Windows, pretty simple choice. If you have Mac, this would be probably Windows 10 or 11. If you have a Mac, it depends on the version you're using. So pay attention. So you will see some binaries for Mac OS 10.13, the other one for 11. And I might have a little bit of bad news. If you have a very old version of iOS, you might need to update it to run RStudio. This is something that happens often with students from Econ 2300. Since you did 2300, I imagine that you have already updated, but this might be the case, okay? So good luck with it. And then you install RStudio, which is our IDE, Integrated Development Environment. Or basically, it's like other languages. If you're doing Python, you don't use Python. You use Anaconda or some other softwares. So to use R, we use RStudio. So R is the programming language and RStudio is the IDE, okay? So the company doing RStudio used to be called RStudio, which made things very easy. But last year, they changed their name to Posit because they're dealing with Python and other things. So we're going to Posit, or you can just Google again. So install RStudio, and it will take you to their website. RStudio Education, probably you want this posit.co. Click that. So they tell you, please install RP4. So they make it very clear. But you can go for Windows. You went straight. But if I scroll down, probably you have options for Mac 11 Plus and then some Linuxes. I've never seen a student using Linux yet. Probably, and that will be if you need for an older version of iOS, you need to look a little bit further. Look, older versions, and you'll be able to install. Okay. So by now, I will assume everybody has R and RStudio installed. From here, I will spend some time going through the basics. Given most of you have used already, I don't plan to spend too long in everything. And so if we have some time in the end, I would like to show you how to use R Markdown. And R Markdown will be really important, not really important, but like it will be really helpful for your assignments if you would like to explore a little bit and use it for assignments. Because it makes life easier, but it demands a little bit of learning. So in the end, I'll show you how to create a Markdown, but of course, then it comes to you to be using it with time and learning how to prepare a report on it. Okay, so let's go. First, RStudio. This is how it looks like. Let me open mine. Open a small window. My plan is to have it in the top corner like this, so we can still see. Oh no, that's not what I want. So we can still see our slide. There you go. You have this little cute over there, RStudio. And let's go part by part. First, we're going to create a new script. So we're going to click here and go to our script. We can type codes in here. So 1+1, enter. This is the console. And if you enter something here, it will give me an answer. But when you want to run a few things in a row, it's not really friendly doing it here. So you create a script. There you have your script. So you can do 1+1 and you can run clicking it here. And you get the same result, 1+1 = 2. The thing is, if you want to do 1+2 and 1+3, you can select everything and run again. And
Francisco,
it will,
we can't see the R. We can only see the PowerPoint. We can't see your R page.
You can't see my so let me do a new share. Makes sense. I'm sorry for that. Let's go back. Can you see everything now? Can you see this?
Yeah.
Here?
Yeah.
Thank you for that. Thank you, Jasper, for letting me know. So this is back here in the background. We created a new script, right? Let me do it again. So I won't save this one. When I open, it was a little bit like this. Click the broom. It's clear. Then I click here and did a script. So after that, let's go. Each of the parts of RStudio. So here is the script. You can save your script clicking here. What else do they have there? Basically, navigate means you can go back to what you did before. For example, let's see if I think navigate, it's only when you have more windows. Then let me try to open something else. For example, this. If I go there, it navigates to the other one. Yeah. And you have a few ones. The one that we use the most is the run button. And if I want, as I said, 1+1, you could click run, and then you have down there. But you can also select and hold Control, or in Mac, Command, and press Enter. It also runs. If you press Enter without holding Control or Command, it just enters like a text editor. Okay, that's it. And then you have a few other things. Compile as notebook. I don't think, do I have this option? I do. Never use. A lot of things here, never use. Some things you can do. Sometimes you want to write something, but you don't want it to run. So it's a comment. You can add this hashtag and say simple addition. Or if you want to, I don't want this code to run anymore, you can do a hashtag there. And even if you control enter, or if you run, it will just print as it's written, but it won't run anything. It won't calculate anything. Okay. What else here I could say? These are all the things that we'll explore later, some functions coming from other places, but pretty much for the script, that's it for today. Let's go to the other part that is very important, the console. In the bottom here, as you've seen before, we were running things and you saw them happening here. Let's say that the R is actually running here. This is just in the script, a list of commands that we send to R and run. R is showing here. You won't see R marked down here as you have there yet. Because you need to open an R markdown for it to show. But this is a terminal, as if you what used to be DOS a long time ago, but you can still do it in Windows. You never use background jobs, never use. So the only one that matters for us in this course is the console. Once again, you can type things straight to the console and press enter, or you can have a script, hold control and press enter, works the same. So this is the console. And now let's look at the tab panes in the right here. Let me move this guy up in there once again. That's it. First, we have the environment. As you can see here, if you want to create a variable, and this variable receives 3, I want to run, I'll click run, and then your variable is stored in your environment or in here. Okay. You could use this to attribute the value 3 to your variable, or I can call var and do this little arrow here and give them also a 3, and it's also there. var received 3. So in R, either equals or this left arrow indicating left work as getting the value from the right and attributing to the left variable. This little arrow here, I like using it because there's a shortcut for it. If you hold Alt and then click hyphen, it creates. So let me write it again. So we have var, hold hyphen, and then 3. Yeah, just a shortcut if you would like to try. So this is the environment, and your variables will be stored here. If you load some data, it will end up in here. You also have history. Look at the things we've been doing, or I think I've been doing a few other things before. But if you want, look at that. You can move 1 + 1. I find it really hard to write 1 + 1. So you can either send it straight to console, or you can send to source. So we just moved whatever we ran in the past and moved here to your script, which would be the source, or you can send it straight to console. You can probably select a few things, and then we will add all those lines. This is history. To be honest, I don't use it a lot, but yep, it's in the training. I think it's good to know. Connections and tutorial, I've never used. It seems like tutorial would be interesting if you want to explore a little bit more, but we'll show another way of looking at the functional documentation. And that's it for this part. Finally, the one in the bottom right. We have here, first, files. You can have a look and see. Let me move so you, sorry, not what I wanted. I will let you see this guy here. One thing we can do is to find where your files are. So for example, I will go home. We have a few folders in there. My files, where are they supposed to be? Definitely not home. You can create a new folder there, and etc. And when you find whatever your files are, let me see, Zoom, for example, Zoom recordings, and you can set that working that folder as a working directory, set as a working directory, or you can also do it through here. Where is it? Session, set work directory. Choose directory is one option. So you will go there and look, oh, where are the files? For me, it would be tutor 3350 01, and this is the folder. Click open, and it just said it's G 2 points, my drive Bachelor of Economics tutor 3350 01, and you will find all the files in that. Other way of doing it, if you save your script somewhere and it's already the correct folder, you can just click to source file location. So it will set the same folder that you saved as a working directory. Okay. Other than files, then we have plots. We haven't run anything yet in the plot, so you won't see anything, but that's where you will see them. As you can see here, you can navigate previews on next plots, you can zoom, you can export it to JPEG and a few other formats, you can delete a plot, or you can clean all plots if your computer is not running really fast at a certain point. Sometimes a good idea to just clean. You'll see by the end of the semester. Next one, packages. Packages shows all the packages you have installed, and if you want to load a package, there are other ways, but one option would be to just click here, survival, for example. You click, and it's been loaded. Now you can use the functions inside of this specific package. If you click, you get to the documentation, and for this, I need to expand a little bit. Documentation for package survival. This one seems massive, loads of functions, so I would just leave it for now. And I think that's the most interesting things that we have for package. Help we will use later. Help, it's where you see how to use functions and some things if you need, but also most of the times it's easier to just Google. And that's it. This is our studio and the 4 panels that we usually work with. Okay, let's go. So now you have your tutorial 1, and there will be two simple data sets that we're going to work, one for question 1, one for question 2. To make it easier, I tend to have on the slide the question already, so we avoid flipping the screens too much in too many documents. If you go there, I'll show you how to get to your tutorial. No, I'll show it now. So 3350. Let's click there. You will have some announcements and everything, learning resources. Then in 3350, in this course, you will have the weeks. Today, this week is week 1. So you click week 1. You will have tutorial 1 in here. And my suggestion is save all the files. We're going to do this tutorial, as you have probably seen before. And my suggestion is to save all the files so you don't need to come back. But first we work with consumption.txt, a text file, and then photonfish.dat, a definition dat. Okay? So let's go back to the slides. First question is, the text file consumption.txt contains observations on the weekly family consumption, expenditure, and income for a sample of 10 families. Let me click. So what we've just done is like where to find it, learning resources, week 1, tutorial 1, and you will find the files. And the other thing is sometimes when you open a data set, you can just open it on Notepad, as long as it's not terribly big, like 1 gigabyte, to have a look at the format before you try to load it in R. So now we're dealing with consumption. Where is it? Consumption. Open with Notepad. Look how small it is. Wait, I can just make it really small like that. So 10 observations, just one column is consumption, the other column is income. And you have a header for the columns. That's an important thing because we usually need to know. And our question, let's go back there. So this is with a white background and my computer is a black background. So first, read the data into R. There are tons of ways of reading and data into R. R has been growing and growing for a long time, and now people keep developing new packages and new ways of doing things. One way of doing things is just to Google. I will start already. This is a text file, right? So read, for example, read txt in R. You find reading data file, txt, csv, R-based functions. If you go there, they will explain how to do things. Look, read table, read CSV, read the lim, and loads more. Today, let's keep it simple. We're going to use read the lim for delimited. We're going to add consumption.txt, but for R to know where consumption is, I will do the following. First, I will save this in the same folder where I have consumption. So this one, and I'll call it 335001 live. Save. There you go. Nothing really important here. I can erase everything. But look what the code we're going to do. My data receives. My data will be our variable. Receives read.delim. And this should not work first, or maybe because we set the workspace being that folder. Consumption.txt. Then header. We saw that there were header for our column. So header equals. Can you see that it's suggesting me already what to do? So if I just add, it is suggesting. So sometimes you don't need to finish what you're writing. You can just click that and you add, or you could just press tab. I find it easier. So header, I press tab, it continues. I will call it true. And separator, this is separated. And this is the way that we indicate it's separated by space. This is tricky because it's empty. There's nothing there. If you did a space, it would not work. So for read delimited, it works like that for space. If you look at the file, where is our file? Consumption. You see there are some spaces in between the columns. So that's what we mean when we're talking about separated. Let me go back here. File there. So that's it. And let's see if it's going to run. If it doesn't, we know the problem. We did, it ran, it opened my data there. Let me clean the previous variables that I created. And now we're going to use just that. Clean. 10 observations, 2 variables. If you go there and click on my data, you will see the 10 observations, and it's not too different than the file we had before, right? It's one column for consumption, one column for income, and all the values, 10 rows. It indicates the number of the row. It's pretty smart. Let's do, I will click the broom, erase our file, and let's call it false. Look at what happens. If I say there's no header. Now we have 11 observations instead of 10. You can also click here. You will see a few things. So as we said, there were no header. The first line, they interpreted as just a normal row, the first row. And there are no names for our columns. So that's how header works. So this is true. You can run again. I'm pressing Control Enter or Command Enter. What else? Separator explained, and that's it for my data. Another error that some of you might find is let's try this, get work directory. And as we did before, it's already in the correct one where I saved the file. Let's say it was not. Let me go to files. Let me go one back, and I will set the parent folder as our set as working directory. All right. Now, if I try to run this line, look, it cannot find. Look, cannot open connection in addition to warning message. So it didn't work. What am I going to do? We go to the right folder. For me, it was tutorial 1, 0.1, and set as working directory. Now you come here, click run, and it runs and creates the data. Sorry, for you to see. I will erase, run it again. Run. I need to at least be on there. You can either be in the line and click run, or you can select a few lines and click run if you want. Okay. So this is get work directory. You could have used set wd and put all the address, as you can see here. Let's say I want to save it in my script. So set wd and my data. Now, let me indicate this is question 1. I will do a comment. So hashtag, because this is not a programming. This is not this is just a comment. And this was the answer for question 1, for A, sorry. Let's continue. Let's go on. So consumption, we use header equals to true, as you can see. Draw a scatter diagram of consumption against income. Once again, if you have a look, scatter diagram, and there will be tons of ways of doing it. Scatter double T. One of them, let's see if that's the one that we're talking about here. Look, plot both of them, a few other things, names for the variables, etc. The idea of showing you the Google is just that if you need something, you just Google. A lot of times it's already there. Someone has been through the process of explaining that thing for. So yeah, clicking. We're going to just do this simple thing. Attach the file, the variable that we have, let's say the data set. And while we're doing that, attach my data. I'm not going to run it right now. Let's go to the plot. We're going to plot income against consumption. We're going to give it a title, consumption data. Then you can keep writing xlab receives income. Then ylab receives consumption. Then pch receives 19. Pretty long line, like not really friendly. Or you can get to a certain point and just press enter. RStudio understand that after the comma, like your command hasn't finished yet. So, for example, we think that this is a way making it look good. It's a little bit organized. Takes a little bit of more lines, but looks quite organized. There's also shortcut to do that. Look, I believe reflow comment. No, reformat code. Look at that. Look what they did. So every single input we enter for the plot function, it created a new line. So it's all organized and identity. It's a matter of taste. Sometimes you want the code to look a little bit shorter. Sometimes you just want it beautiful like that, like organized. It's an option. So the thing is, when I run, R doesn't know what is inc and what is cons. Why R doesn't know that? These variables are inside of my data. So to do that, I need to say, oh, look inside of my data. Then you put a $sign. And then look, a complaint about inc. Let me run it again. Now we complain about cons. I will look my data, $sign, and run. Now we have a plot as we had that. If I do a full screen, you will see how it looks like. pretty much each observation, income in the x-axis, consumption in the y-axis, and you will see there is one possibly outlier there. Something is wrong there. A few things here. So main consumption data, it's the title, xlab, it's the x, y consumption. You will see here. This is what is going in our x first, then our y. And a PCH is the type of little thing that we have in that. For example, you could use 14. Let's see. It became a triangle inside of a square. You could use 10, and it became kind of an aim target, a square and a plus in the middle. And there are a few. If you go there, let's say plot PCH options, you will have a description of them. Let me see if there's a little picture. So you can choose. There are some, you can probably choose colors too. Oh, look at that. These are the ones we have. Okay. Colors will be something different. In the code, let me see. I think it was just call. No. I don't think it'll work like that, but let's give it a go. I need to add a comma. Yeah, they became red. Okay. So that's it. Question answered. We plotted. So let's go to the next one. See, on checking the data, you find that your assistant has recorded the weekly consumption expenditure for family 8 as 900 instead of 90. We knew there was something wrong there, right? Correct this error and redraw the scatter diagram. First, you have the values in there. And let me kind of put it just a little in the corner there. If you go to my data, look where the 900 is. I'm not sure. I don't think you can do it through here. So we need to use R to change the things. Where is this value in there? One thing, I think we're doing C now, right? One thing you can do is just to do my data, and it will print. Look how it looks, what it shows. It shows it like that. You can also, when it's a matrix, this is a matrix of 10 rows by 2 columns. So that's how R looks at those data sets. We can choose to look at value 1 and 1, comma, 1. So this should return just the 70. So just row 1, column 1. If I do row 1, column 2, we should get 80. Enter 80. But which one we have a problem? It would be row 8, column 1, and we don't want it to be 900 anymore. We want 90, right? So look how we're going to solve that. First, let's try to print it. Make sure we're looking at the right one. Row 8, whoops, column 1, run 900. So now we know we're looking at the right one. Now I want that cell, let's say if it was an Excel, it would be a cell, but that space to receive 90 instead of 900. So I'm going to run this one, click run, and look at that. It's 90 now. So that's how you change values inside of your data set. And you can do it in multiple ways. This is just one way of doing things. Now we can run our consumption data again. Let's first click here. First, it was A1 and 90. I can see I forgot to attach the file and show you why we attach. Sorry. Let me go a little bit back quickly. Here for B. If we run attach, then these variables here now are part of R. So now we don't need to write my data and $sign anymore. And let me clean this one. Let's remove. Yes. Sorry, no, I didn't need to remove, but that's okay. I will run it here. Then I will attach. Now we can run this code just by saying cons and inc, because now that I attach my data, it's part of the environment. So just run the plot. And there it is, the plot. But we want to change the 90 here in question C, right? So first we change to 90. Let's check. It's 90 now. Problem is we attached the data. Look at that. We will have to detach the previous one. So detach my data. And now we need to attach my data again. And now this one, following objects are masked. Okay. Now we have the new values. So if I try to plot it again, can you see how it is before here? Look now. Much better, because now the value that was 900 came back, the outlier came back, and now you can see a much better line with the dots that we need for the scatter plot. And that's it. We fixed this outlier. And just to make sense of it, it wouldn't make sense for someone to consume 900 if their income is 120, right? So you can see this little thing sometimes. Okay, that was C. D, compute the mean, median, maximum, minimum values of income and consumption. You might think, oh yeah, let's do a lot of code for that. I will copy this plot down there. It's pretty much the same code, so just copy and paste, it works. Now D. Is a statistical software programming language. So a lot of things related to statistics you have with very short commands, and right at your hand, you don't even need to load different packages. So one thing is a summary statistics. Summary my day. What are they asking? Is it something specific? Income and consumption. So pretty much summary my data. You enter and you get this output down here. Look, minimum, first quartile, median, mean, third quartile, and maximum value. In that column, the same for income. Okay, very simple. So as you can see, it brings out what was asked: mean, median, maximum, minimum, and some other things. There are other ways of doing the things, but yeah, that's pretty much it for D. Now E, let's see. Compute the correlation coefficient between consumption and income. Comment on the result. I think, as I just said, correlation is also something very statistic, and it will be quite easy to do. It's actually probably one of the shortest things that you can do that. Whoops. Now it's E. It's just cork. Cons and inc. We can do that without the my data $sign because it's attached, right? So pretty much, even better. The solution is just we could have done this and it will give just one option, but the solution wants everything. So my data, correlation, my data will give everything. So what this one is doing is the correlation of every column against every column. I think this makes more sense in the video, I think. So you will see the correlation between consumption and consumption is 1, because the correlation of two things, it's pretty much 1, right? Two identical things. The same for income and income. And the correlation between consumption and income is 0.98. If you remember from 2300 or even 1310, the more it looks like a straight line, the higher the correlation. So if you did a regression here, the points, the observations we have are not too far from a linear regression. That's why you have a very high value, 0.98. As I did before, if you want something like As you can see, the order doesn't influence. So this is the same as this, right? And if you're comparing two identical things, it should be 1. Okay, so that's correlation. F. Create the new variables. So we showed before how to create variables, right? You just attribute the value. Look at the solution for this one. First, decons. We want to have just half of consumption. I will put it in the corner once again. And the code will be down there. First, decons receive. We're doing the little arrow. 0.5 times cons. Control Enter or Command Enter. You will see the little decons here already with the value. So it used to be 70 times 0.5. The first value is 35. That's how it works. Lcons is log of consumption. One important thing, if you don't remember from ECON3350, when we say log in R, we mean the natural logarithm, not the log to the base 10. So the base is E, exponential, the Euler number. So yeah, it's not base 10, it's base 3 point something, 2 point something. So log cons, there you go. Then inc. Now to vary a little bit, instead of using the arrow, they use the equal. Now this is income. Inc2 will be income squared. So we put this little hat and 2. So 70 squared. Is that right? Oh, no, it's income. So 80 squared. Oh, that makes more sense. 80 squared, 6,400. So 6,400. That makes more sense for me. Square root income. We receive the square root of income. The simple thing. Enter. Square root of 80, somewhere around 8.94. Yep. Created all the 4 variables. You should see them in here. Next question. Delete the variables decons and square income, and then delete everything. So very simple commands. First, you can remove, and you can remove more than one at the same time. FG. So remove. I could have done one by one. Decons, and then I could do remove square root inc. Look, they're offering me a variable there. I can just press tab and it writes for me. I could run both of them, or I can run just together. Then you click run, pay attention, it should disappear from here. 2 of them disappear, the rest is still there. Finally, to remove everything, FGH, we will use the same remove command, and then we'll ask to remove everything that you can see pretty much in your environment. So list equals to ls list everything. That's a little bit what's happening there. When you run, it ends the environment. A lot of times I start my code by doing this with this line, because you run it once and like, okay, now I want to run everything again. So my first line is this one here. So erase everything. Let's start from scratch. That's how I usually do. Just a recommendation if you guys would like to do the same. And this was consumption and this little introduction to R and how to do a few commands. Okay. Now let's move to Fulton Fish. So Fulton Fish is a famous market in New York, fish market. I added, this is a picture I got it from the internet. Like, is it correct? I don't know. The website looks a lot more modern nowadays, but maybe it's like a long time ago it used to look like that. And we were talking about a whiting fish for the ones that are not very into fishing, this is a little bit what one of the types of whiting fish look like. This is probably how a fisher look like in the US, maybe. So this is the other file. I hope you guys have saved already in the same folder. Photonfish.dat. So another type of file. You could have Googled how to load read.dat file in R. There will be a few options there. When we go to the thing here, when it's a DAT file, usually your computer won't open as easy as consumption. I just double click, they know it's a notepad. .dat, sometimes you might need to look at here, DAT file, right click, open with notepad. This is how it works in Windows. In Mac, it's probably a little bit different, but there's a way of choose what software you want to open the file. Look at that data. They look like they're not separated by space. It looks like separated by tab because everything's really well aligned. It could be tab. Also, pay attention that we don't have a header, so header is going to be false for the next one. So let's go. First, now we have exercise 2. I'll put 3 like that. 2, a Fulton fish market. Let's go. 8. We saw. Let's start. But so at Fulton Fish, the famous Fulton Fish Market in New York City, sales of whiting, a type of fish, vary from day to day. Over a period of several months, daily quantities sold in pounds were observed. These data are in the file photonfish.dat, and description of the data is in the file photonfish.def. Describe the first 4 columns. Just with curiosity, let's have a look at def. I'll try to open this as a notepad too. Open with. I can't remember if notepad reads def really well. Look, you have a little bit of a description of the file, what each of the variables is. As you can see, we didn't have headers, but the .def file has a few headers and a few other things there. Okay, just curiosity. All right, let's go. Describe the first 4 columns. Use R to open the file and name the series in the first 4 columns as date, L price, quan, and L quan. L probably is log. So let's go. We're going to load the file the same way we did before, but this time we're saying header is false. First, I told you that it looks like it's done by tab, right? So let's have it, put it in the button here. So Fulton Fish receives, read the link. Fulton. Since we set the work directory, I would expect the name to come over if I press tab. Sometimes, so as you can see, I press tab and it offers me in that folder there are these files starting with Fulton. We don't want the definition, we want the dat file. Then header is false, header receives. You could write false. It also works if you just press F. And then separator, I said tab. Let's put tab and see what comes. It didn't. Okay, separator value must be 1 byte. So it didn't accept. Another way of saying tab is dash tab. But there's a problem here. Look at that. 1 variable. It looks like more than 1 variable. We have quite a few. So although it looked like there was a tab in between, it's probably not. Let me click Fulton Fish and look, it created just 1 variable for everything, right? We don't want that. So let's remove this tab that I created here. Not a good idea. Let's just run as space. Now we have 15. So yeah, instead of tabs, although it looks very well aligned, it was just space. Did I put, yeah. 15 variables, and now you have one column for each of the things. Okay. Now, next thing, it also asked us to, let me put it there, to give column names to our columns. So when you click, you will notice just variable 1, variable 2, variable 3, variable 4 for the columns. And if you open, you have the same. Let's change that. We want all names from which data set? Bolton fish. Which we can define which columns we want. So I want from column 1 to column 4 to receive. And now we're going to use this function, C, and then we have each of the names. Date, L price. Oops, one. You can see like it's not behaving the way I wanted. I need this inverted commas or quotation marks there. One. Be very careful with this because it can stop running your code. So you want things to be very similar. Enter. Can you see that now we have the 4 names there? Date, L price, Quan, L Quan. Now if you click, you have those guys over there. And that's it. Pretty much what is showing in the slide. Call name, that's what call names does. If you just want to check the names, you could have written the command call names Bolton fish. Enter, and then you have the 4 that we just changed, and the rest are all these for a variable. Okay. Options. All right, let's go to the next one. This was A. B. Compute the sample mean and standard deviation of the quantity sold. When? Let me go. So, sample mean. It is this obvious. We haven't attached anything yet, right? So it's not that. I might need to Bolton fish. And then when you press the $, you come with all the options. I'll choose one. And enter. If I have just written Quan, as I explained before, it shouldn't find Quan. But if I attach Bolton fish, then this starts working again. And I believe I would expect to get the same result, right? Here and here. And for standard deviation, same, even easier. Oops. Let's go to the script. SD, Quan, enter. What happened? Sorry, I pressed something wrong. SD, Quan, and that is it. Pretty much just me and SD. As you can see in the example, we didn't attach, so that's why we're using Bolton fish. C, item C. Test the null hypothesis that the mean quantity sold is equal to 7,200 pounds a day at the 5% level of significance. And now we're investing a little bit on something that we studied in the last lectures of ECON3350, Introductory Statistics. Then probably we saw it a lot during ECON2300, the hypothesis tests. And probably if you did a few other statistics, it's always there. So call on 1310 taught us to do it in 4 steps. So first, what is the hypothesis that we're trying to do? So test the null hypothesis that the mean quantity sold is equal. Oh, I think my fire alarm is going on. Let me just check for 1 second. All good. Not a problem. We're still safe. Hypothesis test, null hypothesis 7,200. Okay, so the null is equals, therefore it's the two-tailed test. The alternative hypothesis, which a lot of times we call H1, it's different than 7,200, right? Then, second step, the decision rule. Reject H0 if the t-test, t-cog, it's greater, like the absolute value is greater than t-crit. Then we calculate the t-crit that we want. It's a 95%, so 1.96 because it's too tired. Some of you might not remember that anymore, but it's a little bit how it works. And then we're going to create this test statistics. It is the average of the sample that we have. So the sample average minus the mu. In this case, our mu is 7,200 divided by sigma hat divided by the square of the number of observations, which gives us this large value here, this big thing, and gives us a 2.26 bigger than 1.96. Step 4, decision. Reject H0 because 2.26 is larger than 1.96. And finally, you write the conclusion. At the 5% level of significance, there is sufficient evidence to conclude that the mean quantity sold is not equal to 7,200 pounds per day. And that's kind of the end of the revision for hypothesis testing. Now let's make it the R style. That's much, I would say, much easier, much straightforward. We write this little line, t-test. So t.test. Photon fish quantity mu equals to 7,200. Enter. It will give you this output here, the same you can see in the corner in there. And let's have a look at it. Look. Do you remember we got, let me scroll up a little bit. We got 2.26. It will get something close to it. It's not rounding, so minus 2.2566, but it's absolute value, so ends up being 2.26 if you round to do decimal places. Also, p-value, remember, they always talk to each other. T-crit, t-test, p-value, and confidence interval. P-value, 0.02601. Since we want a 5% level significance, anything below 0.05 for p-value is good enough. After that, also the confidence interval, as you can see, the lower bounds 5,500 and the upper bounds 7,094. So it doesn't include 7,200. Which is the mu that we're looking for. So reject, reject, reject. Yeah, they always agree with each other. Now, that's it for the t-test. Next, construct a 95% confidence interval for part C. To construct a 95% interval, a confidence interval, this is usually how you use for a sample. It's the sample mean plus or minus the t-crit that you found times the sample standard deviation. So the sigma hat divided by square of n. But the good thing is, as you can see before, the t-test already gives you the confidence interval, and that will be the most of the cases that's what happens when you do a regression, as you remember from 2300. So you will find you could calculate it by hand, but you already have the answer in your t-test. So yeah, that's how things talk to each other, and that's how R makes your life easier, right? Don't need to do calculations by hand. And this is how easy, because R is in a statistical software programming language, that's why it's so easy to calculate those things. Tiny observation there. If you add and subtract, perhaps you might not find the exact same value. And why is that so? Here, we are rounding the numbers to 2 decimal places, while R would use everything they calculate until the end. Another thing, we're assuming a 1.96, and it comes from a Z table, the standard normal distribution. But as we're dealing with sample here, we're actually looking at a t-table, t-student distribution. So there might be some minor differences. T-student distribution, the bigger the sample, the closer it is to a Z. So a lot of times we have a lot of sample, a large sample, so you can just use the Z. But if you put these things together, maybe you won't get exactly the same number. I will be using like all to the last detail of the number, okay? So confidence interval. Let's go to E. Did I not write anything? I didn't write anything because D would be just using the same guy here, right? We have our confidence interval in here. E. What are they asking us? Plot log of price against log of quantity and label the variables L price as log price of wheating per pound and L quan as log of quantity. Then comment on the nature of the relationship between the two variables. Let's have a look. Look at this. No, it doesn't look like a line as before, right? So first, attach photon fish. We've done it before. Now let's do the plot. Let me try to put it here. Plot L1. So just in case you haven't done the attach before, I'll put it photon fish. Run this one. And then plot L1, L price. Then main. So the title will receive log price and log quantity, comma. Can you see the bracket open here? And it's coming. I'm leaving the bracket. We're not closing it yet. We'll leave it to the end. Just a detail there. It's because it's all inside of the plot function. X tab, log of quantity. Next, Y lab label, right? I said tab, it's not tab, it's lab. Log of price of wheating per pound. And finally, our PCH. Yes. Someone, any question? No? Easy. PCH, I'll try 13, just lucky, that's it. What show? It's not fitting my small window, so let's expand a little bit. So figure margins too large, that's the problem. Let's run and look at that. Oh, that's pretty much, I would say, quite ugly. Let me change. I don't want 13, I want 19, like the column. So little dark black dots here, and look at the relationship. How does it look like? So we have quantity and we have price per pound. I feel like the more quantity, we're doing economics, right? Economics course. So the higher the price, more or less quantity should we have? Probably less, I would say. So as you can see, it's kind of a negative relationship, not a very clear line. But if I would draw something, it looks like something more negative than before. We had a pretty clear line, positive line. So the slope would be negative, but the correlation shouldn't be too high, like impressive, close to 1. And we're probably somewhere far from 1. Let's see. First this, then let's calculate the correlation. As you can see, negative and very far from 1. 4 of L1 when L price minus 0.27. Remember what we did before? You can also do the correlation of everything, but because photon fish has 20 variables, look what happens for photon fish. Oh, oops. It didn't even like, look how much it printed. All the 20 versus each of the other. Did I say 20? No, 15 variables. So yeah, that's how it works. It's more not really correlated, just a little bit. And it's a negative relationship, right? Well, okay, that was E. Save your work file to any folder and or on any drive. So saving the work file means saving everything how you have right now in R, saving it so you can continue your work later, or maybe carry it over, on a pen drive or send online cloud to another computer and continue work where you stopped. I'll be honest with you, also something I don't do. I'm not a big fan of doing that. I prefer running the code all over again to make sure the whole thing is running. But well, it's in the training, so let's do it. You can use the save command, save. Then we're going to say list all. So we're not saving a single variable. We're saving everything. ls all. Is there anything? All receives true. Then what is the name of the file? File would be, you have here tutorial01. Little typo there. Let's try tutorial01.r data. So we're saving everything, and everything for us, in fact, is just photon fish. Let's see if it accepts. It did. So when I go back to my thing here, we have tutorial that I saved before, and now tutorial01. Let me do the following. Let's close this. Yes. Now let's go there and try to open tutorial. I want to open it with RStudio. Do you want the load into your global environment? Yes, I do, please. There you go, Photon Fish is back in that. I personally, so if you want to erase everything, you can click here. I would just run the whole thing again. Definitely always save the script. And then you just, for example, I just clicked, hold Control A, selects all. So, or Command A, I think works in Mac too, but please let me know if it doesn't. I could have also select everything, but run. Things happen. And in the end, you have Photon Fish back in there. Also, since I selected everything, question 1 also ran, but in the end of question 1, I had a command to clean everything. So yeah, question 1's not there anymore. If I wanted to run let's clean everything. Oh, nothing's there anymore. Question 1, I would run all the lines before. And we have the plots here. Remember the plots, we can navigate the previous plots with them. So this is the one with the outlier. And then after we fix the outlier, becomes the line and everything else. You can look at everything we've done through here. Okay. And finally, this was the last question of the tutorial. So in terms of the 2 questions in the tutorial, thank you, we finished. But if you want to stay for a tiny bit longer, we have time to talk about R Markdown and how to install it. I would like to show you guys how it works. But if you don't, or if you want to watch it later, thank you for participating. Beginning next week, week 2, it will be we will be talking something more macroeconometrics, okay? So let's go. Bonus, R Markdown. If you want to, when you're doing your research project, you could create, instead of creating a script, you can create an R Markdown. When you click that, if it is installed, it will show up like this. But if it isn't, you will have a screen like this. Creating R Markdown documents require an updated version of the R Markdown package. Do you want to install the package now? You click yes, and it will install more. In my case, it was more than 20 new packages for a clean installation of Studio. It will install everything, and you will see everything being installed here in the bottom. I can show you since we have time. Let me uninstall my R Markdown. Do I not have it? Maybe I don't have it yet. Part. Oh no, it's here. Sorry. Markdown. Markdown. I will uninstall it. This action cannot be done. I just click this little X here. Usually you can do by command, but I'll quickly do it. So if you don't have R Markdown installed, you try to create a new R Markdown, and it will tell you this. You press yes, you will see some things being installed here. It goes to background jobs and it's showing like, oh, we need to install. If it's the first time you're installing, it will happen for 20 packages. Please wait until it's done. Don't click stop. It's not a good idea. Then you go to that other, I'll leave it there. You will go to this other option here. You have the new file like we did a script, but now there's this little RMD in red here, which is an R Markdown file. And we're going to choose PDF because it does look better. It's all right if you want to do Word or HTML, but PDF looks better. I definitely recommend. So it's done. This page, so PDF, test, Francisco as the author, the date. I'll press OK. It automatically brings you a template. It's a little template, simple thing. And what do we do from here? First, we will save it. I'll save it as test. Here, I already have RMD underline test. I'll overwrite it. Yes, I want to replace. And now, so we're going to click knit. So you click here and knit to PDF, this guy there. You will see this looks a little bit different than what we usually have for an script, normal script. So knit to PDF. You will see it processing here. It's like compiler if you know what other programming language. And background jobs. Remember the R Markdown render we saw here? It calls render output created R Markdown test.pdf. So what's going on there? If you open that PDF, you have this file here. And if by any chance it complains and say you don't have LaTeX, it means you need to run this install, run this line, tiny text, column install, underline tiny text, open and close. But from my last attempt, we usually used to have to do that before. But since I just installed R Markdown a few days ago, apparently it installs tiny text automatically. So I think most of you won't need to do that. If it doesn't, if it complains, oh, you don't have text, but we say tech, you just run this little line there and it will install what you need. Otherwise, send an email to us. Let us know that we will help you with whatever is going on. So, okay, let's open the PDF. It was RMD test. Where is my RMD test? In my computer, it opens on Chrome. Look how nice it looks. The name test, you have Francisco, you have the date, R Markdown. This is an R Markdown document. So this is kind of normal text, as if you're typing on Word, then enters the R script and just one line. And then it puts the R output, like the console, what comes out in the console. And then it goes back to our Word document again, and you're writing. So let me show you what's going on in R. Maybe I could split the screen and have both open. Maybe I also want to increase a little bit. So look at that. Can you see the title, my name, and the date? Basically, they are defined here. This is just an opening of not very important, but this is R. What is happening there? Or R Markdown. What is great is R code, and what is not great, like with the white background, it's just text, normal. Having R Markdown a little bit darker or a little bit bigger, it's these two hashtags. If I take one of the hashtags, it's even bigger. I would say testing, and I'll say, let me change Francisco Tavares Garcia. So when you knit, I imagine that it saves automatically. As you can see, it's not red anymore. And if I refresh this guy here, look at that. Testing, Francisco Tavares Garcia. Markdown slightly bigger. I don't think you would see the difference, but yeah. For example, look how they wrote neat with a few asterisks around, so it became bold. And look at that summary, cause. Cause is a database they have. You could also click run current chunk, just a little chunk of R code, and it shows what's going to come out. So this is our Markdown, and this is really handy. Like, I don't know if you use for ECON3350, but if you've done this project before, you would type on Word, then you get a print screen for an R, then you paste the print screen, and then, oh my God, I need to run again because it's wrong. So you have to delete the image and get another print screen and paste it again. Sometimes you need to format. R Markdown does everything for you and already comes out looking like that. So when I did my reports, both for 2300s, particularly this one for 3350, it was just a large R Markdown running with many little chunks of R happening. And it's not a straightforward thing. There is a little bit of a learning curve on how to use, but in my opinion, it's worth for your assignments later. So good luck with it. That was it for the tutorial today. I hope you guys enjoyed. And I will stop the recording now. Let me stop. I'll see you next week.